Scientists have discovered the true ferocity of a huge volcanic eruption.
A volcanic eruption that could happen by the end of the year. A massive underwater volcano about 300 miles off the Oregon coast.
It's one of the coolest things that happens on our planet.
The alert from the United States Geological Survey has just been escalated to red for a massive submarine volcano slumbering beneath the Pacific Ocean, and the implications are both startling and profound. Deep beneath the waves, kilometers beneath the surface, a geological giant is stirring. One that until now has been quietly monitored but never truly feared at this level. The seismic network shows swelling, magma movement, and earthquakes, all pointing to a period of unrest that scientists say could precede a major eruption. This kind of event is seldom acknowledged until too late. The news reverberates beyond the volcano's immediate vicinity, raising questions about what could happen when a mighty underoceanic volcano awakens. Before we start, smash the like and subscribe buttons for more updates. Imagine an immense mountain built from cooled lava, sitting under the sea, gathering pressure like a kettle about to boil. That mountain is part of a longer arc of volcanoes formed by tectonic forces, a hidden bulge of molten rock pushing upward beneath the floor of the Pacific. Already, subtle signs tell the story. The volcano is inflating, shifting huge volumes of rock, and the seismic tremors beneath the ocean floor are multiplying in frequency and intensity. Such behavior suggests that magma is on the move, pooling, migrating, perhaps preparing to rupture the seafloor. Researchers emphasize that this is not some distant hazard off a remote coast kindly out of sight. The ripple effects of such an eruption could surface in many ways, some immediate and others far more insidious. The very act of declaring a red alert signals that experts believe the volcano could go from quiescence to eruption within a time frame that demands preparedness. Red is more than a designation. It's a clarion call. It means that the monitoring agencies consider the odds elevated that a dangerous event could occur soon. It means that hazard zones must be assessed, that the usual buffers of caution may no longer suffice. When a volcano beneath the ocean ventures into a high-risk regime, the usual land-based response frameworks need rethinking. That includes aviation ash clouds from submarine eruptions can reach the atmosphere, coastal regions' tsunamis triggered by sudden seafloor disruption, and global climate effects large volumes of water, steam, and volcanic gases released into the atmosphere. The scale of the underwater environment only amplifies the potential consequences. Under the waves, the mechanics differ somewhat from classic land volcanoes. As magma accumulates beneath the seafloor, it presses upward, deforming the crust, spawning seismic swarms, and perhaps slowly fracturing its own path toward the surface. Because this volcano is covered by tens to hundreds of meters of water, the eruption will interact with seawater, which rapidly cools lava and transforms it into new formations, but also creates explosive steam reactions and potentially large gas emissions. The eruption might reshape the seafloor, eject sediments, and send plumes of ash or steam high enough to be carried by winds. The mixture of molten rock and water adds an element of unpredictability. In some scenarios, eruptions beneath the sea remain contained, but in others, they blow open fast, unleashing pressure in dramatic fashion. The fact that scientists have detected both inflation and seismic unrest suggests this volcano may be approaching that threshold. For coastal communities, even those far away, the waking of this giant is not just a geological curiosity. The ocean is a conduit, and disturbances in its floor can propagate. Submarine eruptions can generate tsunamis, waves that start in the sea, invisibly at first, then build and crash without warning. Even if the seismic origin lies hundreds of miles offshore, under deep water, the wave can travel across oceans. Moreover, the ash and gases released during an eruption can reach high altitudes, being carried by winds and affecting air traffic, even altering weather patterns temporarily. For island nations in the Pacific, for coastal regions, for global aviation and shipping lanes, the stakes are elevated. Monitoring now is intense. Protocols established, but the margin for error tightens when nature takes the initiative. The unusual part about this red alert is the location. Deep beneath the Pacific, away from conventional lava flow hazard zones, but close enough to sensitive ecosystems and inhabited shorelines that the risk is non-trivial. Seafloor sensors detect change, fiber optic cables relay data, satellites measure deformation. One might think that being beneath the ocean offers safety by distance, but history shows otherwise. Large undersea volcanic events have triggered far-reaching consequences. The fact that the volcano is swelling signals that this isn't a routine fluctuation. It could mark the buildup toward a major release of energy. The very infrastructure of submarine monitoring is being tested. Remote instruments, seismic arrays, tilt meters, pressure gauges, and more. If scientists can predict or at least anticipate the eruption of an under-ocean volcano, this could mark a milestone in volcanology. But prediction is far from certainty. The geological context underscores the seriousness. Tectonic plates shift. In this region, the Pacific plate meets others. Subduction may occur, magma accumulates. The volcano forms as molten rock finds weakness in the crust. When we see inflation of the volcano's edifice, it means magma is collecting, perhaps forming a chamber that is pressurizing. Earthquakes signal movement, magma intrusions, rock fractures. When those combine, the risk is amplified. The ocean's pressure slows some effects, but also contains potential energy. Should the barrier hold, tension builds. If it gives way, the eruption may be sudden, with minimal warning. That is why the red alert is a serious matter, not because an eruption is guaranteed, but because the possibility is real and time-sensitive. Consider the consequences of the eruption itself. The volcano may breach the seafloor, lava would flow into the water, generating steam, explosions, and new pillow lava formations. The disturbance could displace large volumes of seawater, which in turn could trigger tsunami waves. Ash and fine particles can be ejected into the atmosphere, carried by winds, affecting air quality, aviation routes, even climate. Gas release, sulfur dioxide, water vapor, carbon dioxide can feed into atmospheric circulation. Marine life around hydrothermal vents could be disrupted. The seafloor topography could shift, altering currents or ecosystems. Even if the eruption remains moderate by volcanic standards, the submarine context makes the risk more complex to manage. When one adds the red alert layer, it means that the scientists believe the escalation is significant. Another layer is the potential for ancillary hazards. Earthquakes associated with volcanic activity may cause submarine landslides, which themselves can generate tsunami waves independent of the eruption. Gas release could damage nearby infrastructure or ecosystems. For shipping lanes and undersea cables, the shocks of an eruption or landslide raise concerns. In an interconnected world, the waking of a submarine volcano is more than a local concern. The potential effect on global systems, climate, ocean circulation, shipping, increases the urgency of monitoring and response. The red alert also compels us to think about warning systems and preparedness. Many coastal regions assume land-based volcanoes are the primary risk. Underwater systems are less well understood. The alert highlights that the undersea realm can change quickly, leaving little time for human response. Communities may need to reassess tsunami evacuation routes. Shipping companies may reroute. Aviation authorities may issue ash advisories. Scientists now must run models. What if this eruption blows a large volume of material into the air? What if a flank collapse occurs? What if the eruption interacts with the ocean in unexpected ways? These are not mere academic exercises. They are practical scenarios that now must be considered seriously because the alert is real. What this event emphasizes is the interconnectedness of Earth's systems. A movement deep below the ocean floor might seem remote, but its effects ripple outward. The volcano's awakening tells a story of hidden forces, tectonic energy, molten rock, water pressure, seismicity, all interacting in complex ways. The world above the waves may not see the early signs, inflation, creeping magma, micro-earthquakes, but scientists do, and they are raising the alarm. It invites the public and emergency planners to pay attention, even though the volcano lies mostly out of sight, because when the eruption happens, if it does, even the remote may feel its impact. Technological advances have made it possible to detect the subtle movement of this submarine volcano earlier than in the past. Underwater pressure sensors, acoustic arrays, remote vehicles, and satellite deformation monitoring combine to create a real-time picture of the volcano's behavior. These tools have shown the inflation of the structure, the uptick in seismicity, the movement of magma. That is why the red alert was issued. The combination of signals has reached a threshold where uncertainty no longer allows for complacency. Even though predicting the exact moment of eruption is impossible, the indicators say action rather than watchful waiting. For regions around the Pacific Rim, especially those with coastal vulnerability, this alert should heighten awareness. Historically, many Pacific communities have built resilience around tsunamis, earthquakes, and volcanic eruptions, but the underwater volcano scenario introduces additional complications. The origin offshore may delay detection of waves, ash plumes may travel further than expected, and response infrastructure may not account for such fast-moving underwater events. The red alert serves as a reminder that preparedness must include the less visible threats as much as the visible ones. The economic dimension should not be overlooked either. Shipping and undersea infrastructure may be exposed, tourism may be affected, aviation may face disruption. An eruption could temporarily alter routes, delay flights, damage marine ecosystems, and impose costs on industries. Governments and businesses alike may now need to factor in the consequences of a submarine volcano entering an eruptive phase. The red alert indicates that such planning is no longer hypothetical. Beyond the practical, there is a broader environmental and scientific dimension. An undersea eruption of this magnitude may release new nutrients into the ocean, alter marine ecosystems, and open new vents for life in extreme conditions. But it may also damage fragile habitats, displace species, and change the chemical composition of seawater locally. The legacy of this volcano's waking will likely be studied for years, not just for its eruption, but for its ecological fallout. The red alert means that scientists will get a live case study of submarine volcanism in progress, an opportunity to expand knowledge, but also a moment to reckon with nature's scale. In the bigger picture, this event adds to our understanding of volcanic risk in the modern era. Land-based volcanoes have always drawn attention. Now, the awakened giant beneath the Pacific underscores that the oceans hold equal, if hidden, dangers. As monitoring technology improves, our capacity to see ahead of eruptions increases. But so does the expectation that we act upon what we see. The red alert doesn't just signify watch out, it signifies this may happen soon. That shift in tone is significant. People may ask, how likely is the eruption? What magnitude might it reach? How soon? The truth is that volcanoes are notoriously unpredictable. The red alert is based on elevated risk, not certainty. But what matters is that the risk is elevated enough to warrant immediate attention. The combination of signs, inflation, seismicity, magma movement, has crossed a threshold. For centuries, human societies have often reacted after disaster. Now the goal is to anticipate and mitigate. But anticipation requires resources, planning, communication, and coordination. When that coordination involves an undersea volcano, the hidden nature of the threat complicates the response. The red alert triggers discussions about early warning systems and how to communicate risk to the public. When a volcano lies under hundreds of meters of water, the first visible signs to people above may be subtle. Small tremors, slight sea surface anomalies, unusual chemical signals. The window for response may be narrow. Public education is crucial. Communities must understand that a hidden volcano is neither lesser nor less dangerous than one rising above land. Coastal residents, maritime operators, governments must be cognizant that an eruption may begin at depth and escalate quickly. The fact that a red alert has been issued means the experts believe such escalation is plausible. The subtext of this event is also a reminder of Earth's dynamic nature. We often live as if landscapes are stable, oceans unchanging, time predictable. But the ground beneath our seas is alive. The tectonic plates, magma chambers, volcanic conduits are all in motion even if we don't see them. The red alert shines a light on that unseen world, reminding us that the boundaries between Earth, sea, and sky are permeable and dynamic. When the giant beneath the Pacific stirs, it asks that we listen, watch, prepare. In addition, the scientific community will use this moment to learn more. A large submarine eruption would provide data on magma-water interaction, seafloor deformation, tsunamigenic mechanisms, and ash dispersal across oceans. It could refine models of how undersea volcanoes behave, which in turn improves forecasting of future events. But learning comes with risk. The red alert says that the volcano is not just of interest but of potential consequence. The boundary between curiosity and urgency is narrowed. Societally, trust in institutions that monitor and warn about natural hazards is at stake. When an organization like the USGS issues a red alert, people will watch how authorities respond. Will evacuations be timely? Will warnings be clear? Will shipping and aviation sectors take the heed? Will the public understand what a submarine volcano red alert means? Past events, such as the eruption of Hunga Tonga Hunga Ha'apai in the South Pacific, remind us that underwater eruptions can have outsized and unexpected effects. The stakes now include not just geological phenomena, but public confidence, readiness, communication, and international coordination. The issuance of a red alert for the awakening volcano beneath the Pacific has drawn the world's attention not just for its scientific implications, but for the profound statement it makes about the planet's volatility. At the heart of this development lies an immense reminder that Earth is still in the process of creation, reshaping itself beneath the surface with every tremor, pulse, and plume of magma. The Pacific Basin, home to the so-called Ring of Fire, is one of the most seismically active regions on Earth. The awakening of a major submarine volcano there is more than a local anomaly. It's a manifestation of the constant battle between the planet's interior heat and the cooling crust that encases it. This awakening may signify deeper changes along tectonic boundaries, suggesting that the planet is entering another cycle of significant geological activity. One of the most fascinating aspects of this event is the role that new monitoring technologies play. Over the past decade, oceanic research vessels have deployed extensive networks of hydrophones, seismometers, and satellite-linked pressure sensors across the Pacific floor. These devices are now feeding back an extraordinary level of detail, revealing the inner mechanics of volcanic unrest that were once entirely hidden. Scientists are now able to visualize magma migration in near real time, mapping how molten rock moves through conduits beneath the seafloor. This technological revolution is allowing for unprecedented insights, but it also exposes how much we still do not understand. The red alert is both a testament to human progress in observation and an admission that nature still operates on scales we can barely comprehend. The seismic data indicate that the volcano's internal system has become hyperactive. Deep earthquakes, once sporadic, now appear in rhythmic swarms, hinting at the pulse of magma chambers expanding under pressure. The seismic signals vary in tone and frequency, which helps volcanologists identify whether the magma is rising smoothly or breaking through rock in sudden bursts. When low-frequency tremors dominate, it often signals fluid movement, a possible harbinger of eruption. The data show that this volcano has entered such a phase. As pressure builds, gases within the magma expand, seeking release. When that release comes, it can be violent, even under immense oceanic pressure. The potential for a massive underwater eruption also carries implications for the global carbon cycle and ocean chemistry. Volcanic gases released into seawater can alter local acidity, feeding complex chemical reactions that influence marine life. Iron and sulfur compounds can stimulate plankton blooms, which in turn affect oxygen levels and carbon sequestration in ocean systems. A sustained eruption could temporarily change the biogeochemistry of a wide stretch of the Pacific, impacting everything from coral ecosystems to fisheries. This isn't just an eruption waiting to happen. It's a planetary process with cascading biological and atmospheric consequences. Beyond the scientific and ecological dimensions, there is the geopolitical aspect. Nations scattered across the Pacific depend on early warning networks coordinated through agencies like the Pacific Tsunami Warning Center and the USGS. A red alert compels these nations to act in concert, sharing data, calibrating models, and coordinating communication. The Pacific Ocean is ringed by major economies, island nations, and vast shipping lanes. Any large geological disturbance can disrupt trade, communications, and even diplomatic relations if the event strains resources or infrastructure. The necessity of transnational cooperation becomes clear when facing a threat that recognizes no borders. Another profound implication is psychological. Humanity tends to view the deep ocean as a remote and passive realm, but the awakening of such a colossal volcano shatters that illusion. Beneath the tranquil surface lies a world of immense power and instability. The red alert exposes how thin the line is between calm and chaos, how easily the Earth can assert its will regardless of human planning. It reminds people that their technological civilization, for all its complexity, exists at the mercy of the same elemental forces that once forged the continents themselves. Researchers are also revisiting historical records of submarine eruptions to refine predictive models. Some past events have produced massive undersea lava flows that reshaped entire sections of ocean floor. Others created floating pumice rafts that drifted across thousands of miles. The current awakening could add a new chapter to that history, offering data to understand why certain volcanoes transition from dormancy to hyperactivity with little warning. Every bit of new information will expand the broader understanding of how underwater volcanoes influence the evolution of Earth's crust. Meanwhile, the natural rhythms of the planet continue. Magma shifts, rocks crack, gases rise. The red alert is humanity's translation of these primal signals into a language of urgency. It represents a collective acknowledgement that something monumental is stirring beneath the Pacific, a living system of fire and pressure preparing to break its silence. In the vast darkness of the deep ocean, a force is gathering momentum, and though it remains unseen, the signs echo through the planet's crust and through the instruments that monitor it. The world waits, aware that every minute brings it closer to a revelation written not in words, but in ash, lava, and steam erupting from the hidden heart of the Earth. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on the USGS issuing a red alert for the Pacific volcano? We want to hear from you. Thank you for watching and see you next time.